Okay, so a quadratic equation here, again, just a little bit more vocab for us. A quadratic equation here basically is going to be, I'm going to call it an equation that has a degree of 2. Okay, basically that's going to mean, I guess, the highest exponent is 2, right? The highest exponent is 2, right? So far we've looked at standard form of a quadratic equation, which I sort of mentioned in the warm-up. Okay, standard form of a quadratic equation is going to be ax squared plus bx plus c equals 0, right? And we solve this by factoring. Okay. Now what we're going to look at today is, an equation that maybe looks more like this: ax squared plus c equals 0. So notice that we have no x term here. Okay, and we're going to solve this one by finding square roots. Okay, so just as we had, sometimes 2 solutions for when we factored, right? We're sometimes going to have 2 solutions when we solve by finding square roots. Now, the leading coefficient of this, right? If we just look, the leading coefficient, or basically going to be the coefficient of the x squared term. In this case, it's actually just going to be a. Okay, so let's look at a few different cases, I guess, that come about when we solve by square roots. Okay, so let's look at instead of calling it ax squared plus c equals 0, they've just called this x squared equals d. Okay, now they're giving us 3 specific cases here. Okay, so again, the first value here is that, again, I'm going to erase this part. Okay, there's still no b term, right? So we're going to call this x squared equals d. Right, now the first case is when our d is greater than 0. Okay, if this is the case, okay, if we get, for example, x squared equals d, it's going to have 2 solutions. Okay, it's going to take the positive and the negative square root of whatever d is. Okay, so again, 2 solutions right here. Okay, and that is if this is true. Now, if the d actually equals 0, okay, or if that constant on the other side actually equals 0, okay, we'll get this, right? So x squared equals d will have just 1 solution, okay, and it'll be x equals 0. But there's just 1 solution here. Okay, and our last case is that if that constant on the other side is less than 0, okay, in that case there's going to be no real solutions. Okay, and so we'll say 0 solutions here. Okay, so again, basically it's like, let's just maybe summarize this. If this is positive, there will be 1 solution. Okay, if this is negative, if this is 0, there will be 1 solution, and if this is negative, there will be no solutions. Okay, so let's take a look at a couple example problems. I think we'll find this actually pretty easy. Okay, so this one says solve each equation. I've got x squared equals 4. And so to solve this, the opposite of squaring something is taking the square root of that. Okay, and so since this is positive, I'm actually going to have 2 answers here. So when you take the square root of each side, okay, we have to remember every time when we take the square root of each side, you have to put plus or minus. Okay. So, and then we know that the radical 4 is actually just 2. So we have 2 solutions here. X equals plus or minus 2, because we know that 2 times 2 is 4, and negative 2 times negative 2 is also 4. Okay, on this next one, okay, on x squared equals 5. Okay, again, the constant on the other side is positive, so we will have 2 solutions here. Okay, I'll take the square root of each side to undo the square, and I'll get x equals plus or minus, again, never forget the plus or minus, radical 5. So since radical 5 is not a perfect square, we do not have to do any more work. We can just leave that alone. Okay, now since x squared equals 0 in part C here, since our constant on the other side is 0, there's actually only going to be 1 solution to this problem. Okay, so if I take the square root of each side, I know that the square root of 0 is just 0. Plus, this would be really silly anyways if you just said plus or minus 0. Okay, so our only answer here is just 0. Okay, so that's one answer that we just have there. Okay, and then finally on this last one, we notice that if we take the square root of each side, we actually take the square root of a negative number, okay, which we cannot do. So we basically say that this example there will be no solution. Okay, let's take a look at a couple more. Okay, in this one we have x squared equals 16. So our constant on the opposite side of x squared is positive, so there will be 2 solutions. So when we take the square root of each side, we'll say that x equals plus or minus, or the square root of 16 is just 4. So this would be our final answer. Okay, looking at part B, this time I have x squared equals 81. Since 81 is a positive number, I know that we'll have 2 solutions here. Okay, and so I will take the square root of each side by saying x equals plus or minus 9. Okay, let's go ahead and continue on to part C. On part C, we have x squared equals 7. Again, 7 is a positive number, so we know that there will be 2 solutions. Okay, this time I will get x equals plus or minus radical 7, because 7 is not one of those perfect square numbers. Okay, and then finally, on part D, we've got x squared equals negative 12. When we take the square root of both sides, we find that we take the square root of a negative number. So again, we would have no solution for this one. Okay, now let's just take a quick second and look back to maybe part B. Okay, if I'm to solve this for 0, if I were to put this in standard form, it would look like this. X squared minus 81 equals 0. Okay, we should know that this is the difference of 2 squares pattern, right? So if this has to multiply to a times c, it has to multiply to negative 81, and it has to add to our b term, which is going to be 0 in this case. That's just negative 9 and positive 9, right? So we get x plus 9 times x minus 9 equals 0, okay? And then we'd solve to get x equals negative 9 and x equals 9, okay? Notice that those are the exact same as these solutions right here. Okay, so again, that's just kind of something to take note of. Okay, in the next example, we'll just go through how to solve some equations here that are a little bit more complicated, and we'll be done for the day.